Hello, 6th grade math friends. This is Chapter 6.5, Percent of Change. We're going to begin this lesson by solving word problems involving percent increases and decreases. Our first problem involves something called a markup. A markup is the rate at which the price of merchandise increases over the cost. So the increase pays the merchant's costs. For example, in the cafe, we have a slight markup. That's where our profit comes from. So if we purchase our food at $3 per serving and sell it at $5 per serving, our markup is $2. So let's work through a percentage problem that uses markups. Mr. Sato sells fish at a 60% markup. He pays $3.75 per pound for haddock during 1 week. At what price per pound will he sell the fish? Okay, so the question is, if he pays $3.75 for the fish himself, and he's going to mark it up by 60%, what would you as his customer pay for that same piece of fish? All right, there are two possible ways to solve this. Method 1 asks us to find 60% of $3.75. And we do that by multiplying 60 over 100, 60%, 60 per 100, times $3.75. That gives us an answer, once we multiply it all the way through, of $2.25. So the markup is $2.25. That means the final price of the fish is $3.75 plus $2.25, or $6 per pound. Okay, now let's look at method 2. In method 2, we'll set up 100% being equal to $3.75. To find the value of 1%, we would take $3.75 divided by 100, and then we would take 60%, and to calculate 60%, we would multiply the value of 1%, which is 3.75 divided by 100, times 60, to once again get a final answer of 2.25, or $2.25. Once again, we add the original cost, $3.75, to the cost of the tax, $2.25, to get a final cost of $6 per pound. Let's work another problem like this together. At a post office, the weight of the mail at 10 a.m. was 80 pounds. 2 hours later, the weight of the mail had increased by 30%. Find the weight of the mail at noon. Okay, so we know the weight of the mail at 10 a.m. was 80 pounds. We know it's going to increase by 30%. So let's calculate the final weight. Let's use method 1. Method 1 would have us take 30%, which we would rewrite as 30 over 100, times 80, to figure out what 30% of 80 would be, and that would be 24 pounds. To calculate the final weight, we'd simply take our starting weight, 80 pounds, add the 24-pound increase to get a final weight of 104 pounds. Okay, now let's do method 2. In method 2, we set this up like a rate problem, where 100% of our weight, is 80 pounds. Therefore, 1% of our weight is 80 over 100 pounds, or 0.8 pounds. So if 1% is equal to 0.8 pounds, then we need to multiply 30%. 30 times 0.8, which gives us 24 pounds. Once again, we add it all up to finish up. 80 plus 24 equals 104 pounds. Here, once again, you can see that if you wish to do so, you could actually multiply in this step right here. You could multiply 130 times 0.8 to get 104. And that would, because really what you're figuring out is if the starting weight is 80 pounds and it increases by 30%, the weight that you're calculating is 130% of the original weight, or the 80 pounds. So if you wish to do it that way, you can think of it as calculating 130%, or 130 times 0.8 to get the 104 pounds. It's the same process, you're just doing it in a slightly different order. Do it whichever way works best for your brain. Now try this problem on your own. The price of a new car was $22,800 in April. However, the price of the car was reduced by 5% in May. What is the price of the car in May? This is a little different than the other two problems we've done because it's asking you to find a percentage and then subtract it from the total, as opposed to finding a percent and then adding it to the total. However, I'm positive that you can figure it out. Press pause while you work, and when you come back, we'll introduce a new type of problem. Go! Now we're going to solve word problems by finding a quantity that's represented by a percent. William had a length of brass chain. He used 30% of the chain to make some necklaces. The remaining length of the brass chain was 385 centimeters in length. He then used 25% of the remaining chain to make keychains. So what was the original length of William's brass chain? Okay, let's draw a picture to help us visualize how this works. So if this represents the 100% that William began with, he's going to use 30% to make necklaces, so this part is gone. And this is our remainder, which represents 385 centimeters, or 70%. What we have here is the 30% that's already used. Make sense? Okay, so now let's solve. We begin by simply writing mathematically what we drew a picture of here, which is that we have 100% of the length of the chain. William uses 30%, so we're going to subtract that away, leaving us with 70% to work with. That 70% equals 385 centimeters, correct? So 1% of the length of the chain will be equal to 385 divided by 70, which equals 5.5 centimeters. I used my calculator. Finally, we want to know what the 100% of the chain was that we began with, right? So we're going to take 100% times 5.5 centimeters that represents our 1% and get 550 centimeters. So the original length of the chain was 550 centimeters. Now let's move on to the second part of the question. The second half of the question asks us what was the remaining length of the brass chain after making the keychains. Well, now we have a 100% that is equal to 385 centimeters, right? Because we're using 25% of the remainder to make our keychains. So this represents 100%, so we have two segments left, one that represents 75% and one that represents 25%. Okay. We want to know the value of this piece, right? Because we want to know how much is left after we make the keychains, and we use 25% of the remainder to make the keychains, or 25% of 385 centimeters to make the keychains. All right, so let's once again write mathematically what we just drew a picture of. We're going to begin with 100%. We're going to use 25%. leaving us with 75%. If 385 centimeters equals 100%, we want to know what 75% of that 385 would be. We could rewrite that as 385 times 75 over 100, or 75 per 100, giving us, and I'm going to use my calculator for this, 288.75 centimeters. So the remaining length of the brass chain after making the key change was 288.75 centimeters. Let's try another problem like this. I'm going to help you set up this next practice problem, but then I want you to complete the computations on your own. It goes like this. One Friday, a restaurant received enough orange juice for a week. After the weekend, the restaurant's orange juice supply had decreased by 24% to 76 quarts. After Monday, the supply had further decreased by 20%. In Part A, I want you to calculate what was the original amount of orange juice received. Okay, so what do we know that we can use to set this up? There was a 24% decrease to 76 quarts. So 76 quarts represents what percent? Okay, figure that out and then go on to answer Part A. Press pause while you work, and when you're ready, press play again and we'll go on to Part B. Okay, here's Part B. In Part B, I want you to figure out how much OJ was left after Monday. Remember, on Monday, they took the 76 quarts and they used 20%. So the question really is, what's 80% of 76 quarts, right? Because we're taking 100% minus 20%. We know our 100% is equal to 76 quarts, and then work from there. Okay. This problem wraps up Part 1 of Chapter 6.5. When you watch Part 2 tomorrow, we'll begin by finding percent increases or decreases to solve word problems, as well as some other percentage word problems. See you then.